Hi, my name is Trevor Klee. This is the logical reasoning process for deductions and inferences. So, a bit of introduction about me. I've been an LSAT tutor for around 6 years now. Scored a 175 on my own LSAT, and you can find more information about me. My website, trevorkleetutor.com. And I also sell books on the LSAT on my Gumroad page, which is gumroad.com/Trevor Klee. All right. So let's talk about LR. Specifically, let's talk about deductions and inferences. So if you guys have watched my videos before, you'll know my general strategy for logical reasoning is to always treat logical reasoning as an argument, first and foremost. And what does that mean? Well, it means we have to treat it we have to first recognize the premises and the conclusion. So the premises lead to the conclusion. Because premises, therefore conclusion. Because, therefore. And that's going to be our general approach for all logical reasoning in general. We start off with premises, gets to a conclusion. Now, deductions and inferences, which is what we're talking about today, are going to be a little different than most of our logical reasoning questions. Why? Because deduction and inference questions are missing conclusions. They only have the because portion, they don't have the therefore portion. So, how do we answer these? Well, the way I like to answer these is by carefully laying out each piece of the reasoning and then combining pieces of reasoning to make conclusions. So we have our because. We're going to lay out 1, 2, 3. And then in our answer choices, we're going to find our therefore. So sounds simple enough when I lay it out like this. Can be a little tricky when I, actually try to put it into place in actual questions, which is why I thought I would show some questions here. So these are questions from my book, the LSAT Logical Reasoning Process, which again is available on my Gumroad page. I've got a bunch of questions, bunch of fully detailed explanations. A lot of people have said it's helped them a ton with the LSAT, so check it out. Anyways, on to the question. So question number 1, classic deductions and inferences question. We've got a bunch of sort of arbitrary statements. They don't have the same common sense logic to them as the rest of LR. They're really exercises in formal logic. So if a phone charger has a USB port, then it can be used with laptops. If the phone charger can be used with laptops, it can be used with tablets. None of the chargers manufactured by Ace Industries can be used with laptops. So that's our premises. It's our because. And then we get if the statements above are true, which of the following must be true? Sometimes I get people asking me, well, how do I know that there's no conclusion? How do I know this is a deductions and inferences question? Well, the must be true is always a really good hint. If you see must be true, that means there's going to be no conclusions in your initial stimulus, and you need to find your conclusions, your answer choices. So before we jump into our answer choices, let's see if we can actually lay out this initial stimulus in the way I was talking about, where we lay out each piece of the reasoning, then the conclusion should fall out. So I've got reasoning 1, which is if the charger has a USB port, then it's laptops. Then it can be used with laptops. Now, if the phone charger can be used with laptops, it can be used with tablets. So notice how we repeat laptops here. Laptops, then tablets. And then we get none of these specific chargers of Ace chargers can be used with laptops are laptops. Now, what do we know from here? Well, if none of the ACE chargers can be used with laptops, or as I, shorten it here, they are laptops. Well, for one thing, I can't know for sure that they can be used with tablets, right? We have to be a little careful here. It's not that they can't be used with laptops. I just don't know for sure that they are, right? It's possible there's some other way. Maybe they're tablet specific chargers that don't work with laptops, but I can't know for sure they can be used with laptops. One thing I can say though, is they definitely don't have a USB port, because if it had a USB port, then it could be used with laptops. So can't have USB port. If they did, could be used with laptops. So let's go through. At least some of the chargers manufactured by Ace Industries can be used with tablets. No, that's not really at all. If a charger can be used with laptops, it has a USB port. That's just reversing it. That's like a classic LSAT trick. It only goes one way. If it has a USB port, then it can be used with laptops. Or in other words, if a phone charger has a USB port, then you can guarantee it can be used with laptops. Or in other words, saying that a phone charger has a USB port is sufficient to say that it can be used with laptops. None of these go the other way. C, none of the chargers manufactured by Ace Industries can be used with tablets. This is exactly the mistake I was talking about before. We don't know if they can be used with tablets, but it's possible they can, right? I can guarantee that if a phone charger can be used with laptops, it can be used with tablets. I can't guarantee the opposite. If a charger can be used with tablets, then it has a USB port. That's very mixed up. E, none of the chargers manufactured by Ace Industries have a USB port. That's already the answer we picked up, right? We just reversed A, or reversed this initial statement here. So hopefully you're getting some sense of what I mean. We're laying out our reasoning and then our conclusion falls out. All right, let's try another one here. So this one's slightly different. This is a different type of deductions and inferences question. We still know it's deductions and inferences because it must also be true. But this one's less if-then, and it's more mathematical. So we're going to take a slightly different approach, but we're still taking the approach of laying out our reasoning to lead to our conclusion. So most of the food prepared by the zoo staff last week was eaten by the monkeys. The zoo staff prepared more food last week than they ever have before. However, most of the food the monkeys ate last week was from sources other than the zoo staff. So let's lay this out. So most of the zoo staff are monkeys. More zoo staff than before. Most monkeys are not zoo staff. All right, so this is my abbreviation for saying most of the food was eaten by the monkeys, but most of the food the monkeys ate was not from the zoo staff. There are more zoo staff than ever before. This is almost like a paradox. They're almost asking us to resolve a paradox here. How is it possible that most of the food the zoo staff prepared was eaten by the monkeys, but most of the food the monkeys ate was from sources other than the zoo staff? Well, it must mean that the food that the zoo staff prepares, right, maybe represents like 10% of what the monkeys eat. Or in other words, the monkeys eat a lot of food and the zoo staff prepare only a small part of that, even though most of the food the zoo staff's preparing goes to the monkeys. So something we can say is maybe something like, you know, the portion of the food that or like the amount of food that the zoo staff prepares is a small part of what the monkeys eat, even for the entire zoo. So let's see if we can get something that's sort of along that line. So A, the monkeys ate more food last week than ever before. No, that's not really along that line, right? I don't know if the monkeys ate more food than ever before, because after all, even though the zoo staff prepared more food than ever before, we already know that's only a small part of what the monkeys eat. The zoo staff gave more food to the monkeys last week than they ever have before. Tempting, but no. I mean, it's possible that, before the zoo staff, gave like 99% of their food to the monkeys, and now they're giving 51% of their food to the monkeys. Even though they prepared more food than they ever have before, that 51% of the more food than they ever have before is less than 99% of somewhat less food. There's another source that gave more food to the monkeys than the zoo staff. This is a trick answer. This is one you have to really pay attention to. See, this says another source, but we only know about sources. So we don't know if there's another singular source that gives more food to the monkeys than the zoo staff. We just know something like, there are a bunch of sources, or, maybe there are more sources, but we can't say for sure there's one source that's giving more. D, the total amount of food eaten by the monkeys last week was greater than the total amount of food prepared by the zoo staff. So that's actually correct, right? So that's sort of what we were talking about. How is it possible that most of the food prepared by the zoo staff is eaten by the monkeys if most of the food that the monkeys eat is not from the zoo staff? Well, the monkeys must be eating way more food than the zoo staff's preparing. Or in other words, total amount of food eaten by the monkeys last week is greater than the total amount of food prepared by the zoo staff. And then E, the zoo staff's prepared food last week represented a greater share of the total food eaten by the monkeys than ever before. No, I mean, that's, again, sort of messing up, like saying they prepared more food last week than they ever have before. I mean, we don't know about a greater share. All right, so answer is D. Hopefully this quick lesson has given you an idea of exactly how I approach deductions and inferences by laying out my premises, seeing how they combine together to get me my conclusion. If you want more lessons like this, you can like and subscribe to my YouTube channel, which currently you're on. You can also check out my logical reasoning book that I took these examples from. It has a bunch more examples like this in every section of logical reasoning. And then I've also got some stuff on my website, trevorcleetutor.com. All right. Thank you very much. Hope you enjoyed.